The universe plays host to a multitude of objects that are incredibly interesting and unusual. One of these objects is Hogg's object. This object has vastly astonished scientists and everyone interested in space because it possesses a truly fascinating structure. Today, together with you, we are going to take a detailed look at this object and put forward ideas about what it might be. Before moving on to our video, if you enjoy this kind of video, don't forget to subscribe to my channel, like my videos, and leave a comment for new video ideas. Now, if you are ready, we can move on to our video. First of all, when the large-scale structures of the universe are examined, galaxies are generally grouped under specific morphological classes. Among these classifications are categories such as elliptical galaxies, spiral galaxies, and irregular galaxies. For example, our own galaxy, the Milky Way, is a barred spiral type of galaxy. However, there are some objects, bodies, and structures in space that fall outside these classifications and push the boundaries of current theories. This is exactly where Hogg's object stands as one of those exceptional structures, constituting an extremely critical example for understanding galaxy formation, dynamic evolution, and cosmological frameworks. Hogg's object was first discovered in 1950 by Arthur Allen Hogg at the Palomar Observatory. As can be understood from its name, the object was named after the person who discovered it, which is already a very common occurrence in space exploration. In his initial observations, Arthur Allen Hogg could not fully understand the nature of this object and even thought for a while that it might be a planetary nebula or an optical illusion. However, subsequent detailed scientific research, spectroscopic analyses, and deep space observations definitively revealed that this structure is a system on a galactic scale. Furthermore, astronomers also revealed the object's distance from us by measuring its redshift value. The object was approximately 600 million light-years away from us, and this distance showed that Hogg's object occupies a position that allows for both observation and detailed analysis. Later, teams beginning to observe the object in more detail discovered that the diameter of Hogg's object is about 120,000 light-years. This value is so massive that it is very close to our own galaxy in terms of size. However, morphologically, the object is a very different structure from our Milky Way. While in spiral galaxies like the Milky Way, stars are distributed along spiral arms around a central core, in Hogg's object, stars are concentrated in an extremely regular ring form. This ring has a thickness of approximately 20,000 light-years and is situated between a highly sharp inner boundary and outer boundary. One of the most striking features of this object is the strange void located at its center. This void is roughly 40,000 light-years in diameter and lacks a dense stellar population in the classical sense, yet the term void does not represent an absolute vacuum. Very low-density stars, gas clouds, and presumably dark matter are present in this region. Despite this, in terms of observable light, this area appears almost completely dark. This situation, my friends, shows that the mass distribution of the galaxy is out of the ordinary, and scenarios like this constantly puzzle scientists. Later on, the stars in the ring structure began to be examined, and surprisingly, the vast majority of these stars are young, blue, and high-temperature stars. These types of stars usually have short lifespans of just a few million years. This indicates that active star formation continues in the ring region. This is also a puzzling situation. As you can see, friends, many things regarding this object stand in flat contradiction to everything scientists have known up until now. Anyway, the occurrence of star formation along such a regular ring suggests that gas density reaches its maximum at a certain radius. This provides important clues regarding the dynamic structure of the galaxy. Spectroscopic studies, on the other hand, have revealed to us that the stars in the ring region are rich in metals. In astronomy, the term metal encompasses all elements other than hydrogen and helium. Metal richness indicates that stars formed over multiple generations, and that previous stars dispersed heavy elements into the environment through supernova explosions. This situation shows that Hogg's object has a long-term evolutionary history rather than a one-time formation process. In the central region, older stellar populations have been detected. These stars are generally redder in color and possess lower temperatures. This indicates that star formation in the center ceased a very long time ago. This age gap points out to us that the internal dynamics of the galaxy have changed over time. This galaxy alters itself continuously, just like a living biological structure, and makes these changes blatantly obvious. One of the truly important things for scientists is the dynamic structure of Hoag's object. To understand the dynamic structure of Hoag's object, galactic rotation curves were examined. These curves show the rotation velocities of stars in different regions of the galaxy. The data obtained revealed that Hoag's object possesses a mass distribution far different than expected, and yet again, scientists found something to be astonished about regarding this object, especially the observed rotation velocities in the ring region, suggest that a significant amount of unseen mass, meaning dark matter, is located here. Since dark matter does not interact with electromagnetic radiation, it cannot be observed directly, but its presence can be detected through its gravitational effects. The distribution of dark matter in Hoag's object might be very different compared to classical galaxy models. At least that is the estimation of scientists. If dark matter is distributed irregularly, as scientists estimate, and if dark matter is at a low density in the center and concentrated at a certain radius, this situation could cause baryonic matter, meaning normal matter, to organize itself in a ring shape. One of the most debated topics regarding Hoag's object is its formation. One of the most interesting hypotheses put forward on this matter is the collision hypothesis. It is known that many ring galaxies are formed as a result of another galaxy passing through the center. In such events, density waves resulting from the collision push stars and gas outward, creating ring structures. However, no evidence of such a collision has been found in Hoag's object. Neither is there a galaxy in the vicinity of this galaxy that could have entered into such an interaction, nor have structural irregularities that occur after a collision been observed. This situation separates Hoag's object from classical ring galaxies, and furthermore, the symmetry of this object is nearly perfect. Galaxies formed as a result of a collision usually display asymmetries, irregularities, and remnant structures, but in Hoag's object, the ring is extremely uniform and homogeneous. Another hypothesis is known as the resonance model. According to this model, stars and gas within the galaxy can enter into resonance in specific orbits, forming ring structures. This situation is generally seen in barred galaxies, but no bar structure has been detected in Hoag's object. This weakens the resonance model. Aside from this model, an alternative approach is that this structure could be the result of a special condition that occurred in the early universe. Small variations taking place during the formation of galaxies in the early periods of the universe can lead to large-scale structural differences over time. Hoag's object might be the result of such rare initial conditions. Scientists unable to obtain definitive information regarding this object later began to monitor it with high-resolution observations made by the Hubble telescope. As a result of these observations, scientists noticed that there is a smaller, ring-like structure at the center of Hoag's object. This inner ring was much fainter and smaller compared to the main structure, but this situation showed scientists that the galaxy might possess a multi-layered structure. Furthermore, this structure suggests that multiple dynamic events might have taken place during the galaxy's evolutionary process. Along with all these peculiarities, Hoag's object is a highly isolated galaxy, meaning there are no other large galaxies in its close vicinity that could enter into a strong gravitational interaction with it. This isolation also shows that its formation was independent of external factors, and this makes the role of internal dynamics and dark matter distribution much more important. Moreover, observations on this object have not been conducted solely with telescopes. Scientists created computer simulations of this object, and by examining the structure in more detail, they began to test a multitude of things within this framework. As a result of the simulations, it was revealed that the formation of such an object or structure is extremely low in probability. Simulations generally support either collision scenarios or resonance models. However, a model that can fully reproduce the features of Hoag's object has not yet been developed. For this reason, Hoag's object is considered an open problem in modern astrophysics and serves as an important laboratory for testing theories of galaxy formation and evolution. More detailed observations to be conducted on this object, especially data to be obtained with next-generation tools like the James Webb Space Telescope, could contribute to solving this mystery. If you remember, a moment ago I mentioned that this structure was thought to have formed as a result of a collision, but due to the lack of any trace of a collision and the absence of another galaxy near this galaxy, this theory was thrown into the trash. Well, certain circles did not throw this theory into the trash immediately, but rather tried to extend the theory and fit it to the galaxy's current structure. These circles put forward that Hoag's object experienced a collision in the past, but the traces of this collision might have been completely erased over time. As you know, normally structural disruptions that can be observed for a long time occur after galaxy collisions, but if the collision took place a very long time ago and the galaxy dynamically restabilized itself, these traces could come to levels that cannot be detected today. Even though this scenario is put forward to explain the symmetry of Hoag's object, current observations do not strongly support this possibility. Furthermore, the presence of a supermassive black hole at the center of Hoag's object has also been brought up by scientists in a certain circle. Even though this thought might sound absurd, it has become a subject of very serious debate. Most large galaxies house black holes at their centers with masses of millions or even billions of solar masses. These black holes affect the dynamic structure and evolution of the galaxy. However, no strong evidence regarding such a structure has been found in Hoag's object. If there truly isn't a large black hole at the center, this situation creates a very serious exception in terms of galaxy formation theories. Just think about it. At the center of most large galaxies discovered so far, a supermassive black hole is present, and this includes our Milky Way galaxy as well. Then you look at a structure thought to be a galaxy, and you find no trace of a supermassive black hole. This situation will require you to make changes to many things you know. This is actually where science becomes beautiful. Many things you accepted as true and definitive up until now change completely as a result of conducted research, and you begin to observe many things anew. So, as you can see, friends, this object is truly highly interesting with all sorts of features and harbors a wealth of information waiting to be discovered. Although scientists still haven't decided what this object is, many people among the general public call this object a galaxy. Because of this, we also refer to it as a galaxy. I hope that in the coming years, scientists will be able to observe this object, or rather this galaxy, in much greater detail, and we will learn almost everything about it. So, what do you think this object is? Don't forget to state your ideas in the comments, and with that, I say goodbye to you. I hope you liked and enjoyed my video. Don't forget to hit the like button below and subscribe to my channel to support me. See you in our next video. Take very good care of yourselves. Goodbye.